Hello friends, I am Professor Dattu Patel from LG Institute of Engineering and Technology. Today I am taken on lecture Power Series Solution of Ordinary Differential Equation. Consider a homogeneous linear second order differential equation P0 of x d square y by dx square plus P1 dy by dx plus P2 of x y equal to 0. That is equation number 1, where P0, P1 and P2 are polynomials of x. Now dividing the P0 of x by equation 1, we get d square y by dx square plus P1 of x by P0 of x dy by dx plus P2 of x by P0 of x y equal to 0. Whatever the polynomials form which is multiplied by dy by dx, that is indicated by P of x, and whatever the polynomials form which is multiplied by y, that is indicated by q of x. Now d square y by dx square plus q of x dy by dx plus q of x y equal to 0. That is equation number 2. And equation number 2 is also known as standard form. Now power series solution of equation 2 about a point x equal to x0 depends on the following definition. First definition is ordinary point. A ordinary point x0 is called ordinary point of equation 2 if p of x and q of x are both analytic at x0. Ordinary point, which is also called the regular point. Another definition is singular point. A point x0 is said to be singular point of equation 2 if either p of x or q of x or both are not analytic at x0. Next one is regular singular point. A singular point x0 is called a RSP of equation 2 if x minus x0 p of x and x minus x0 square q of x both are analytic at x0. Next one is irregular singular point ISP. A singular point x0 is called an ISP of equation 2 if either x minus x0 p of x or x minus x0 square q of x or both are not analytic at x0. This all the definition we understood in a simple ways by a chart, so we can easily memorize. Types of singularities of differential equation: d square y by dx square plus p of x dy by dx plus q of x y equal to 0. First one is ordinary point, another one is singular point. When we put the values of x equal to x0 in p of x and q of x and we get the finite values, then we can say that x equal to x0 is an ordinary point. Similarly, put the values of x equal to x0 in p of x and q of x and we get the infinite values, means undefined, so we can say that x equal to x0 is a singular point. Singular point is further classified as a RSP and ISP. Now put the values of x equal to x0 in equations x minus x0 p of x and x minus x0 square q of x, and solution is finite, then we can say that x equal to x0 is a regular singular point, and put the values of x0 in equations x minus x0 p of x and x minus x0 square q of x, and we get the undefined, means infinite value, so we can say that x equal to x0 is a ISP. Now we solve the one example of this topic. Discuss singularities of differential equation 1 minus x square y double dash minus 6x y dash minus 4y equal to 0. First, whatever the differential equation which is given in question, which is converted into the standard form. For converting the standard form, dividing by 1 minus x square, and we get differential equation is y double dash minus 6x 1 minus x square y dash minus 4 by 1 minus x square y equal to 0. Now whatever the coefficient which is multiplied with y dash, that is indicated by p of x, and whatever the coefficient which is multiplied with y, that is indicated by q of x. In denominator portion of p of x, minus is common, minus minus cancel out, and factorize the denominator portion, and we get 6x upon x minus 1 into x plus 1. Similarly, minus common in denominator portion of q of x and cancel out, and factorize the denominator portion, and we get 4 upon x minus 1 into x plus 1. Now put the values of x0 equal to 1 in p of x and q of x, and we get the infinite values. And similarly put the values of x equal to minus 1 in p of x and q of x, we get the infinite values. So we can say that x0 equal to 1 and minus 1 are not analytic. Hence x0 equal to plus or minus 1 are singular points. So x belongs to R, minus 1 and 1 are ordinary points. Now we check about the RSP or ISP. For the point x equal to 1, then x minus 1 p of x and x minus 1 square q of x. Put the values of p of x and q of x, which is 6x upon x minus 1 x plus 1 and 4 upon x minus 1 x plus 1. X minus 1 cancel out, and remaining term of 6x upon x plus 1, put the values of x equal to 1, then we get the 3, which is finite values. Similarly, x minus 1 whole square, 4 upon x minus 1 x plus 1, x minus 1 which is cancel out, and remaining term is 4 into x minus 1 upon x plus 1. Put the values of x equal to 1, and we get the 0 which is finite value, since x minus 1 p of x and x minus 1 square q of x are both analytic at x equal to 1. Hence x0 equal to 1 is a RSP. Similarly, x equal to minus 1, then x plus 1 into p of x. Put the values of p of x is 6x upon x minus 1 x plus 1, x plus 1 which is cancel out, the remaining term is 6x upon x minus 1. Put the values of x0 equal to minus 1, then we get 3, which is finite answer. Similarly, x plus 1 square q of x, put the values of q of x is 4 upon x minus 1 into x plus 1, x plus 1 which is cancelled out, remaining term is 4 into x plus 1 upon x minus 1. Put the values of x is a minus 1, then we get 0 value, which is finite, since x plus 1 p of x and x plus 1 square q of x are both analytic at x equal to 1. Hence x equal to minus 1 is a RSP. In this example, we got the ordinary point as well as regular singular points. Now, if we will find the series solution of ordinary point by a power series method and series solution of a RSP by a Frobenius method. If you have any queries, then contact me. Thank you so much.